Frances Elizabeth Allen was an American computer scientist who worked for IBM starting in the 1950s all the way to the early 2000s. Um, Frances has won many awards and has a very important legacy in computer science, in the works of parallelization and compiler optimization. She was born and raised in Peru, New York, and eventually went on to earning a bachelor's of mathematics from the University of Albany in 1954, where shortly after she started teaching and eventually grew disinterested and got a master's in um, mathematics, where she because she wanted to further pursue her knowledge and education. That same year in 1957, when she got her master's degree, she started working at IBM as a teacher teaching Fortran, which was a new high-level assembly compiler language that just came out that year. She was teaching it to researchers who were at first skeptical of the language, but soon after her teaching, she proved it to be a very useful and um, extremely valuable language, which would eventually carry into the future and um, change compiler optimization forever. After teaching, her next big project was the development of the MAD system, which stood for Monitored Automatic Debugging System, which was used to debug early operating systems at the time. And she worked on the software for it, and this eventually led to many of the implementations we see today in modern IDEs and debuggers that are used even on modern systems today. After working on the MAD system, she eventually moved to the Alpha Language Design Team, which was a language design team that created a new high level language, which was different from most at the time because it could create new alphabet sets beyond the standard domains that most languages would use, which would be like integers and just the regular alphabet, decimals, stuff like that. This language was revolutionary when combined with the stretch harvest machine, which was started in 1959. This was named the IBM 7950, and it was a one of one project based off the stretch machine, which was then given the code name Harvest as a project for the NSA to decrypt codes. She worked on the machine and also served as a liaison for the NSA in assisting with the machine and kind of being like a translator to how it worked with the people who worked at the NSA and the people who worked at IBM. The machine was capable of reading tapes at 1.4 million characters per second, which was incredibly fast at the time and was used to decrypt uh, many codes for the US government. It could read in programming languages such as Fortran, Alpha, as I explained, and autocoder. Working on this project, as well as languages involved, um, made significant steps for computer science at the time in terms of compiler optimization, and were eventually carried over into the high level languages that we see today, which is why she played such a crucial role in this category of computer science. So Ptran was her last big project, which stood for Parallel Translator. This was a system that was made for automatic parallelism, and it was a unique type of compiler optimization at the time because not many systems ran in parallel, which, as you know today, it's much more common, and which is why this project was so important. Um, she used a lot of dependency graphs and like physical drawing representations to work on this, and which is now used today all the time by many computer scientists to see outcomes and how data is connected. Um, Alan worked on this for 15 years and was arguably one of her biggest accomplishments at the company. Towards the end of her career and after retiring in 2002, she received the Turing Award, which is one of the greatest achievements a computer scientist can achieve, which means you made a significant contribution to the science as a whole, which will be lasting. And she also received an award to be in the Women in Technology International Hall of Fame, as she was one of the first women to really be recognized and um, played a crucial role in representing women in technology, which was not always as common back in the old days. She also received the Augusta Ada Lovelace Award for the Association in Women in Computing for her contributions to the field. So many important awards and recognitions of her work. Um, as for her legacy, she'll always be remembered as a teacher, a programmer, and just a computer scientist in general. Also as a mentor for women who are trying to break into the tech industry, as it was back in the day, it was common for companies to see women as not being able to do certain roles, just such as programming and other things. And she kind of just paved the way for women and just any diverse groups to be able to make it into that industry. And so this, on top of her work um, in technology and just the achievements that she's made as far as parallelism and compiling and just optimizing compilers, she'll forever be remembered in the computer science community and just shows how important she was to both women and uh, programmers and computer engineers alike.